Good day. This is a continuation on the lesson of directional derivatives. So we will now use the second formula. So we have here the directional derivative of function of two or three variables in terms of partial derivatives. It says here for a function that is differentiable at a point, directional derivatives exist in every direction from the point and can be computed directly in terms of the first order partial derivatives of the function. We have the theorem A. It says here if f of xy is differentiable at x sub 0, y sub 0, and if u equals u sub 1i plus u sub 2j is a unit vector, then the directional derivative in this notation exists and is given by the formula. We have here it is equal to the partial derivative of the given function with respect to x evaluated at x sub 0, y sub 0 times u1 plus the partial derivative of the given function with respect to y evaluated at x sub 0, y sub 0 times u sub 2. Then we have theorem B. If f of xyz is differentiable at the given point x sub 0, y sub 0, z sub 0, and if u equals u1i plus u2j plus u sub 3k is a unit vector, then the directional derivative in this notation exists and is given by the formula the partial derivative of the given function f evaluated at x sub 0, y sub 0, z sub 0 times u1 plus we have the given function evaluated at x sub 0, y sub 0, z sub 0 with respect to y times u sub 2 plus the partial derivative of the given function x sub 0, y sub 0, z sub 0 with respect to z times u sub 3. So let us work on this first example. So it says here, find the directional derivative of the given function denoted as d sub u f. So this is in the direction of the unit vector at the given point, where the given point is at 0, 0, and this is your function in 2 space, and this is the unit vector given. So we have here the corresponding formula to be used. So the first step is to find the partial derivative of the given function with respect to x and then with respect to y. So we now have this notation f sub x at xy is equal to getting now the partial derivative. So this is ln u. So let's recall the formula of derivative of ln u last time. Let's say this is with respect to x. So this is now ln u is 1 over u times the derivative of u with respect to x. And of course, the other variable here, which is y, will be considered as constant. So that we have here ln of 1 plus x squared plus y squared. The partial derivative will just now be, so you have here 1 over u. So u is 1 plus x squared plus y squared. Then taking now the derivative of your u. So taking into consideration that y is constant, so 1, since this is also constant, the derivative is 0, then plus you have x squared, the derivative is 2x. Then y squared is 0. So therefore, when you multiply now this resulting derivative, so we have here now this as 2x all over quantity, or just simply 1 plus x squared plus y squared. Then if we're going to evaluate now, because we're going to evaluate it, so we have this now as f sub x at 0, 0. So the result is 2 times 0 is 0 over 1 plus 0 plus 0. because x and y are both 0, so the answer is 0. So that is your f sub x evaluated at 0, 0. Then we're going to find also the partial derivative of the given function with respect to y. So it is denoted as f sub y at xy. So this time we're going to differentiate the given function with respect to y now. So this time x will be constant. So let's just follow this formula written here. Ln u is 1 over u, and u is 1 plus x squared plus y squared. Then take the derivative of this u starting with 1, so that is 0. This will be 0 also because they are both constant. Then y squared is derivative is 2y. So I'll just write here 1 times 2y is 2y. Then if we're going to evaluate now, given by the value of the point at 0, 0, so we can see also that the answer here is 0. So with that, the directional derivative of the given function f in the direction of u is equal to, using this formula, so that is 0 multiplied by u1, which is 1 over square root of 10, plus 0 times your u2 is negative 3 over square root of 10. So the result, we have this as 0. So this is the answer for the first example here.